Mario has 10 science fiction novels on a shelf in his bedroom. How many different ways are there for him to arrange the books on the shelf, right? So he's got 10 different books. Okay. Can he use a book more than once if he's putting them on a shelf? No. Okay. So the first place he'd have 10 to choose from, then what? 9, 8, so on, so on. What's a shorter way we could write that? Yeah, we do that factorial, 10 factorial, because we're going to count all the way down to 1. Okay, so by the time he got to the last spot, there'd only be one book left for him to put in that spot. Okay, so if we do 10 factorial, we can use our calculator to do that. Okay, anybody remember how we get there?
Math probability 4.
Yeah, math probability 4. So we type in the 10, the math probability 4. It gives me the exclamation point. What do we get? 362,000? 880. So there's that many different ways he could put.
0, 0.
Oh, is it 0, 0? Sorry.
Isn't it 3 million?
It's 3 million. I got my commas in the wrong spot. 3 million. All right. So a lot of different ways we can arrange those books. Okay. So makes you glad that if you think about how many books we have in our library, there's a system for putting them out, right? Because that'd be a whole lot of different ways they could set the library up and we wouldn't know what was going on. All right. That's just for 10 books, given how many books they've got, right? All right. So our learning, y'all, I didn't even change the board today. I'm on the struggle bus. Sorry. Okay. I'm thinking 2 more wake ups and I get a week off. That's all I'm thinking about. Okay. So we're going to talk about combinations today. Yesterday we talked about permutations. Today we're going to talk about combinations. And then how do we calculate those, the shortcut way that we'll look at it, and then using the counting principle and combinations to do probability. So we'll do a little bit more probability today, and then we'll be done with that. Okay? Anybody a Wendy's fan in here? I like the nuggets more than I like the burgers. Spicy nuggets, dip them in a Frosty. Oh, it's so good. Okay. Sorry. Try it sometime. Trust me. Okay. All right. Or their French fries in a Frosty. That's good too. Okay. But the spicy nuggets in the Frosty is good too. Because you get the burny and the cold at the same time. Oh, it's good. Okay. Anyway. Sorry. All right. So a few years back, Wendy's had a takeout bag which said there are 256 ways to personalize a Wendy's hamburger. Luckily, someone was paying attention to math class, so that was the actual advertisement, okay? So we want to know if they were right. Were there or are there really 256 ways to make a hamburger at Wendy's, okay? So let's take a look. So Wendy's offers 9 topping options for their hamburgers, and Mr. Wilcox only wants 3, okay? So, and sounds like how many possible ways can he choose 3 toppings if the order matters? All right. So meaning we're not going to repeat a topping. So I'm not going to do tomatoes, and tomatoes, right? I'm going to do tomatoes, pickles, and something else, right? All right. So if there are 9 things to choose from, so we're doing our categories, but he only wants 3. How many can he does he have for the first topping? He's got full 9. How many after that? 8. And then after that, 7. Okay. So those are his only options. The order mattered. Okay, so this is the same thing as a permutation, 9, pick 3, all right, that we talked about yesterday. All right, the order mattered, and we picked 3, and there were 504 ways, okay, he could make his burger. All right, so this was a permutation. Okay. All right, so he picks ketchup, mustard, and onion, all right, on his hamburger. And so we want to try to figure out what are the possible ways that you could put these toppings on. Okay, so we only have 3 things to choose from this time. Okay, so we only have ketchup, mustard, and onion. All right, so we're still doing our categories. Well, let's count again. So I have 3 things to pick from the first time, then how many? 2, then 1. So there's 6 different ways. Right? That we could put it on there. We could do ketchup, mustard, onion. We could do mustard, ketchup, onion. We could do onion, mustard, ketchup, right? So there's 6 different ways we could put them all together. Question. Does the order of those toppings really matter? No. Okay, I would say no. All right, is ketchup then mustard the same as mustard then ketchup? I would say that it doesn't matter. Okay, Because would it still taste the same? Yeah. Okay. It would taste the same, right? It didn't matter what order I put mustard, ketchup, and onions on there. I'm going to taste mustard, ketchup, and onions. All right? That's what I'm going to taste when I do it. So, okay. Well, let's think about this. All right? How many ways could a person order a hamburger from Wendy's with 3 toppings if the order of the toppings doesn't matter? Okay? If the order of the toppings doesn't matter. And so it's a little different process. This is what we refer to as a combination. Okay? Order does not matter. Okay? And the formula for a combination, it's kind of like doing a permutation. We think about the options, then we take out things that might repeat. Okay? Well, the good news is our calculator knows that, and it'll just do it for me. Okay? So if we know for sure, all right, that there are 9 different things, but we're only going to use 3 of them, and the order doesn't matter, we're going to do that combination. So instead of a P, we're going to do a C. We're going to take 9 things and choose 3 of them. Okay, 9, choose 3. And the good news is we're going to get to it the exact same way we did the NPR thing from yesterday. All right, so to do that, we're going to go to math, probability, and this time we're going to choose NCR. All right, so let's jump over there and look at that. Let me get my calculator up. Hold on. Okay, so, right, so math, we're going to arrow over to our probability, and number 3 is the combination one, the NCR. And so I had 9 toppings available, but I'm only going to choose 3 of them. So I can make 84 burgers, all right, with picking only 3 toppings. Okay, so NCR, and James, yours would be just like yesterday. Put the 9, then the probability, then the other. Okay, so we would have 84 ways that we could order a burger. Okay. All right, so here's what I want us to do. I want us to kind of look at a chart and see if we can kind of figure out how some things work, right? How some things work with combinations to get me to probability, right? And so in order to figure out the total number of ways that we could order a hamburger, we've got to find the number of ways to order no toppings, 1 topping, 2 toppings, so on and so forth. So we're going to do a bunch of different combinations, okay? So you're going to take a second here and you're going to do all these combinations on your calculator for me, all right? We're going to look for some patterns. So here's what we're going to do for the first one. We've got 9 things, but I'm going to choose none of them, okay? And we're going to get a number. I've got 9 things, and I'm only going to choose 1 topping. I've got 9 things, choose 2, okay? So I want you to do that for all of those numbers using your calculator. Let's fill in that chart. You'll see some interesting things when you get all those numbers here in just a second. Y'all, it's gonna be cold tomorrow for your senior field picture, okay? And remember to bring your ID. All right, so that's how they'll check y'all in when you go out there. So,
Always do like inverse, like a certain amount.
what do you mean inverse?
So like it's like 0 through 4 is 1 9 34.
Mm-hmm.
5 through 9 is 1 26.
Goes the opposite direction? Yes. It splits in the middle and repeats. It's gonna be cold for real. Like the high tomorrow is like 40 something, 50, and it's gonna be windy. Yeah, it's gonna be windy. So you're definitely probably gonna want a hoodie or a jacket.
So essentially, once you already got like that first half, you don't even have to do the second half.
All right. So one of the things that Cameron's noticing in the table is once you've done the first half, it seems to repeat itself and go back the other direction for the second half, and that's true. Okay, that's true, and it's true every time. It's just kind of how the math works. So let's see if we can figure out how many total ways we could order a hamburger. Well, these were all my different options. So what would I need to do with this all these numbers in this table? Just add them all up, okay? Yeah, or add one side and multiply by 2, all right? Either one would work, right? So if we added them all up, all right, to get the total, I think you get 512. Okay, total ways. So I think if you add that up, multiply by 2, you get 512 ways. So the question becomes, was Wendy's advertisement right? How many ways did they say they could make a burger? Yeah, what was the real way? 512. Okay, so that was poor advertising. Their advertising person didn't really know math. Okay, so that's what we use combinations for. Let's talk about all the different arrangements when order does not matter. Okay, so let's consolidate our notes and then let's look at a couple of examples and we'll show you how to do some probability with this. All right, so when we're talking about a combination, all right.
This one.
Yep,
Yeah, I know they were wrong, but like if they would have multiplied that number by 2, they would have been right.
they would have been right, so they only did half, right?
The halves.
That's right, they left out half the numbers. All right, combinations. Order does not matter. Okay, and we'll use that in CR. Okay, we're going to use our calculator to do it every time. Okay, so we'll use the calculator. We don't have to calculate that by hand. Okay, it involves a factorial and some other stuff. So, but we're just going to do it, let the calculator do its thing. Okay. Now, I want to talk about the probability piece. Okay. And I think once we do some of this probability, it'll make more sense than what I'm about to show you, okay? So it's going to be the probability of an event, okay? On the top, it will be the number of outcomes in our event, so whatever we want to happen. Over the total outcomes possible. So that doesn't change. But the cool thing is we're going to get both of those numbers using combinations. All right. And what I want to do is show you an example. So let's you write that down and then I'll walk you through a little example. I think that will explain that. Then we're going to do some examples. All right. So we'll use our calculator a lot today. Okay. Alrighty. So here's our example. Let's say we want to find the probability that I'm going to pick 8 students from a class of 30. Okay. There are 20 juniors and there are 10 seniors in that class. All right? But they get specific in this probability, and they say, you know what? Let's make it interesting. I want the probability that I'm going to get exactly 5 juniors and 3 seniors. Okay? So, all right, we're going to get specific. I want 5 juniors and 3 seniors. Okay? Brooklyn. You already know what I'm about to say. All right. So, let's talk about my total number of students in the class, okay? So this is going to be a combination. How many students are there in the class? And how many total am I choosing? 8. Okay, so that's going to be my denominator. All right, 30, and I'm choosing 8. All right, but in my numerator, we're going to get specific. All right, because I want 5 juniors and 3 seniors. So we're going to do 2 different combinations, one for juniors, one for seniors. All right, so let's start with juniors. How many juniors are in the class? 20. But how many of those 20 am I picking? 5. Okay, times. All right, and now we're going to do the seniors. How many seniors are in the class? 10. And how many are we picking? 3. Okay, so what we're going to do is we're going to type this in on our calculator just like it's written. Okay, we can do the big fraction. So on the top, we've got juniors and seniors, so it's specific to those 2. On the bottom, it's the whole class. All right, and the total that we're picking. All right, so that's our choosing. That's the difference. Okay, so if I go over here to my calculator, the first thing I'm going to do is alpha y equals. All right, because it will let me do those 2 combinations on the top, which is nice. All right, so math, probability, and I'm going to choose number 3. And my first one was 20, and we're going to choose 5. I'm going to arrow out of that and hit a times. Right? Then math, probability, number 3, and this time we're going to do that second one, which was 10, and I'm choosing 3. Right? And then we put our denominator one in.
Where did you get the bar?
Alpha y equals.
Okay, so
Choose the first one. Yep, gives you a fraction bar. And then on the bottom, we'll do the whole group, which was oh, nope, not that. Math, probability, NCR, 30, and we're going to choose 8. Okay, so that's how you can type it in. That's the nice thing about the calculator. You can type it all in at one time. All right, we hit enter, it's going to give me the number. All right, which is nice. All right, so that's my probability. Okay, that's my probability. So about 0.32. Okay, about 0.32. Okay, anybody need help getting that typed in because that's important. So that we can use it. Okay. All right, so let's look at what some of the questions are going to look like. All right. So Janine wants to set up a playlist with 8 songs on her phone. She's got 50 songs to choose from, including 15 by Taylor Swift. Janine's device won't allow any song to appear more than once in a playlist. Okay, so do we care what order it plays the songs? No, we just want it to play some songs. Okay, so it wants to know how many different sets of 8 songs are possible for her playlist. Assume that the order of the song doesn't matter. Okay, nor is it specific to Taylor Swift. Okay, so we're going to use a combination. How many songs were on her device? 50. And how many are we choosing? 8. Okay, so 50, and I'm choosing 8. All right, so that's all I have to do for that. I can type it in on my calculator. I'm going to trust y'all can do that. Let me give you the answer. It's a bunch. 536,878,650 different playlists. All right, that's a lot of playlists. Okay, we shouldn't get tired. All right, with just 50 songs. How many of y'all have way more than 50 songs in your playlist? Yeah, me too. Okay. My husband and I went to the beach several years ago for fall break, and he just put his phone on shuffle, all of his music. No song repeated, nor did I know 95% of them. So I was like, okay, y'all ever heard of a group called the Butthole Surfers?
Nope.
I had not, but yeah, okay, I knew Quinn would know. So every time it would come on, I'm like, what is this? So we go from Butthole Surfers to Johnny Cash to George Strait to AC/DC, Metallica. Like, it was insanity. I was like, who are you? Who did I marry? Anyway, I mean, it was never dull.
Yeah.
Okay? It was never dull. All right, so let's look at this one. How many 8-song playlists contain no songs by Taylor Swift? Okay? So this time, do I want to use all 50 songs? No. I only want the ones that don't have Taylor. Well, how many Taylor songs are there? 15. So how would I figure out how many are not Taylor? 50 minus 15 are not Taylor, which would be how many? 35 songs are not Taylor. Okay, so we would do 35 this time, and I'm going to pick 8. All right, so I didn't use all of them. I just used the ones that didn't have Taylor in them. So that would give me like 23,000 or so, or 23,535,820. Okay, so that's a bunch too. Okay. All right, so now let's jump into a probability. Okay, let's jump into a probability. So it says, suppose Janine decides to let her phone select an 8-song playlist at random. Okay, what's the probability that none of the 8 songs is by Taylor Swift? Well, good news for us, we've already done the legwork for this. Okay, so we're looking for probability that it's not Taylor. Okay. So first of all, I need to know how many total playlists would there be. Well, that's what we did in number 1. That's 50, choose 8. Okay. And then how many were not Taylor? That's what we did in number 2. So 35, choose 8. So that's how I would set it up. Okay. Does that make sense? So it's just a little different. We're going to use combinations to get these numbers because they're big. All right. Those are those 2 numbers we already used. Okay. When you do that division and you're doing a probability, what should your decimal or what should your number always be if we're doing probability? There's some rules for probability. Anybody remember? It has to be less than 1. Yeah. So if you get 2.7, you did something wrong. Okay, so it's a check. If it's a probability question, it should never be bigger than 1. Okay, so now let's look at this. Let's look at this one. Okay. Now, this time it wants the probability that exactly 2 of the songs on the playlist are by Taylor. All right. So we got to think about that. We want the probability that 2 are from Taylor. And then if it's 8 songs, how many would not be Taylor? 6. Okay. So that's the probability we're actually doing right there. We're doing 2 different things. 2 that are Taylor and 6 that are not. All right, so 2 that are Taylor and 6 that are not. The good news is my denominator is still all the songs on the list. Okay, 50, choose 8. Okay, so if we want 2 that are Taylor Swift, all right, we'll finish it when we get back. Then we'll be about ready to go.